and yeah. Okay. Now I have shared the screen, and we'll go to that, and you can see. So the screen is visible to all of you.
Yes, sir.
Okay.
Yes, sir.
Yes,
Now you can see the things. So this was the model that we have up till now we have gone through. So we have created this model. We have applied. So we have completed with material properties, then section properties. Then we have also cleared with what no only that much. Then we have assigned. Uh, Supports, and now we'll try to see how we can go ahead with application of loading. Now most of the time I will explain you that through a sketch first, and then we'll go into that. uh, See, whenever you are using any software, software will have some load cases. Now these are considered as primary load cases. Okay, so let's say primary load case may be dead load, then it may be live load, then it may be superimposed dead load. So I will call it as a superimposed dead load. In the superimposed dead load, you may have other categories. You may use a separate load case for wall. Then you may use a separate load case for floor finish, or you may use another separate load case for any other, say, POP, or hanging on ceiling, or maybe any other load which is not a dead load, but it is a permanent load. So that all all you can instead of all these can be included in HDL. Okay. Then you may have a lateral loading as earthquake in X direction or earthquake in Y direction. Then you may have a wind loading, let's say wind loading in X direction and wind loading
Y direction.
in Y direction. So all these are considered as static load cases. Why static, and what is the meaning of static load case? A static load case is a load case which is independent or does not vary with time, right? Whatever may be the time, once it is applied, it will remain plain, and that's why it is called a static load case. Then you may have a dynamic load case. Dynamic load case means these are the load cases which vary with time, or it may vary with position, or say I will say space. It may vary with space. Okay. Right now we will be dealing with only these three, and then we'll be dealing with this, and then we'll be dealing with this, and finally we'll go for dynamic. But right now we are going to apply the loading. All these dead load, live load, and superimposed dead load, these you may consider them as a vertical load or gravity loads, because they are acting vertically downward. These loads act vertically, laterally, towards the positive axis or towards the negative axis. The same about X, same about Y. So that's why we say EQX positive, EQX negative, or EQY positive, EQY negative. But this right now we are not dealing with this. We'll deal it with uh, after say 1 or 2 sessions, because before that we'll go through what are the loading, how the loading due to earthquake will generate, then what are the different types of uh, uh, definitions that are used in earthquake, and then we'll go for dynamic. So what is the difference between earthquake static and earthquake dynamics? And then we'll go for wind X and wind Y. Okay. So right now we are concentrating on load number one, which is dead load number two, which is live load, and load number three, which is STL. Now, all these are also considered as primary load cases. Now, what is the difference between primary load cases and combination load cases? Okay, so the thing is that these are primary load cases. I will say primary. That means all these load cases will be analyzed separately or individually by the software. And later on, when you go for combination, when you go for combination, okay, when you are going for combination, you will see that combination will include dead load plus live load, or 1.5 dead load plus 1.5 live load. Now, what is the basic difference between these combination load cases and primary load cases is that the software will analyze individually for all these primary load cases. He will keep the track of analysis result of dead load, live load individually. And if you ask the software to get the result for dead load plus live load, then he will combine those or algebraically sum, and the summation will be given to you as a result. So the software will not, any software, not only ETAG, any software will not analyze this case. He will simply find out the result of dead load, find out the result of live load, and it will algebraically sum up and will issue you the results. Clear?
Yes, sir.
So let's say if I want the result for 1.5 dead load plus 1.5 live load, then what software will do? Software will take the result of dead load, apply a factor of 1.5, then he will consider result of live load, apply a factor of 1.5, and then sum it up as per your suggestion, and he will produce you the result. So the basic difference between primary load cases and combination load cases is that the software will always analyze for primary load cases, and combination results will be found with this uh, law that you are providing: 1.5 dead load plus 1.5 live load, or maybe 1.2 dead load plus 1.2 live load plus 1.2 earthquake in x direction or wind in x direction, etc. So all that laws will be applied to the results of primary load cases. Now, how this can happen? Because you know that we are going for linear static analysis. See, this term is very important. Linear analysis. And in linear analysis or linear elastic analysis, a principle of superposition holds good. Clear? Hello?
Yes, sir.
Yeah. Now we'll see with this background, now we'll see how it is applied. So for that, what I have to do again, the first thing is that I have to define the primary load cases. Now, if I go to define, and if I see here load pattern. Now this is the load pattern. This is a specific terminology in ATAB. Load pattern will define your primary load cases and it will be applied in load cases. Okay, so click on that load pattern. Now by default you will have a dead load defined as its inbuilt facility. You will have live load defined as its inbuilt facility. Now, let us understand this box. So, what is the meaning for this? See, define load pattern. So, in this box, we can define various load patterns. Okay. Now, the first is dead load. You can see here is the name, so that name of the load case will appear over here. Then type of the load case will appear over here. And if you click on this, you will see that these many primary load cases can be defined in this dialog box. So the first is dead load, second is super dead, then it is live, then it is reducible live, then it is roof live, then notional, seismic, seismic drift, wind, snow, construction sequence analysis, then pre-stress final, pre-stress transfer, and if you don't have, if you have some another load case which is not included in this, you can apply it in other. That means a load type, almost any load type can be defined. Clear? Hello.
Yes,
Yes,
sir.
sir.
Now see the third column, which is saying self-weight multiplier. Okay. Now what is this self-weight multiplier and why it is required? Now, now again, I will say that you can compare it with some other software, but I will say that don't compare. Try to find out or understand the philosophy that has been employed or applied in this software. This software says that you need not worry about dead load. That is due to self weight. Okay. And what is self weight? Weight of the member itself. Yes or no? Hello.
Yes, sir.
Yes, sir.
Now how it will be determined? So let me tell you that when you have defined material, you have defined uh, this gamma, that is weight density. Okay, that was in kilonewton
Per
per
meter cube.
cubic meter, whatever may be. For concrete, you are assuming 25, then for any other, you may go for 20, let's say mortar or BB masonry, etc. So if you follow IS codal provisions, there you will get under IS 456 uh, part 1, you will get uh, wet density of various materials that are applied in civil construction, right? So there for concrete, you know that wet density for concrete is considered as 25 kilonewton per cubic meter. Okay. Now
Yes, sir.
every element. Hello. Yes, somebody is asking something. Yes. Hello.
No, sir. No, sir.
Okay, okay. So here we are getting the wet density or a specific weight of the member. Let us say I'm having this member. Now this member may be beam or maybe anything else. I will say that L. When you are drawing a member from one point to another point, you are giving information about length. And when you are defining a cross section, you are giving information about width of the section and depth of the section.
Yes.
So you are providing three dimensions, that is depth, width and length. So if now the software knows everything, he know the specific weight, he know length, he know width, and he can understand depth. based on your information. So it is very simple for software to calculate weight of the entire element. Clear? Hello.
Yes, sir.
Now, now, now the terminology or the concept that is used in ETAB is that if you are giving specific weight, you are giving length, you are giving width, and you are giving depth, then the self-weight calculation of self-weight can be carried out by software, right? Okay. Is it possible for software to calculate? Because it will calculate 25 multiplied by volume, that is L multiplied by B multiplied by D. So you will see that it will be something in terms of kilonewton. Yes or no?
Yes, sir.
So the calculation of self weight can be carried out by software, and that's why here we need not worry about supplying the self weight of the material. So it may be beam, it may be slab. See, in slab, what is happening? In definition, let's say in definition, you are providing thickness. In definition, you are providing thickness. And when you draw the slab, you are providing L and you are providing B. Already in definition, you have provided T. So is it possible to calculate? Because the material is defined, because you are saying M20 or M25 or let's say concrete. Okay, so M25. So it is a concrete. So the specific weight is also given through the material definition. L is given, B is given, T is given. So it is very simple for any software to calculate self weight. So dead load that is arriving. 1 minute. सर मी कॉल करतो नंतर. हो हो. Okay, so you can calculate. Now that's why in ETAB you don't have to supply a self weight. It is already calculated or it can be calculated by software. So software says that just let me know what is the self weight multiplier. Okay, so when you are clicking on dead, so this I will go, I will use entirely for self weight, and that's why I will use self weight multiplier equal to 1. Okay, so gamma multiplied by volume multiplied by 1 will give me self weight. Now, if I go to this live load, now once see you cannot have multiple instructions to the software which are contradictory to each one. So that's why here what we are following, see every time. So whenever you are applying any primary load case, software will apply self weight into it. So if you are defining, let's say you are defining some 10 number of different primary load cases, and everywhere you will add self weight. So is it good? Hello?
Yes, sir.
Is it good? Because then see, if I am defining 3 primary load cases, everywhere he will apply self weight. That means 3 times self weight will be considered. Do we need that? See, self weight will be accounted only once, not always. Yes or no?
Yes, sir.
So for that, so you will provide a self weight multiplier 1 only in one case, and that I will say that you preferably use that self weight multiplier 1 only in dead load case. Okay, in live
sir.
load case you will apply multiplier equal to 0. See how we are getting our solution correct. See here also, as per the instruction, software will apply self-weight into whatever live load that you have provided. But see what is happening. Let's say you are applying, let's say you are applying 2 kilonewton per square meter as your uh, live load. Okay.
Yes, sir.
Then software will say that I will add self weight into this. So he will add self weight something like this. Gamma, whatever will be the density of the material, multiplied by L, multiplied by B, multiplied by D. And now you are saying that apply a multiplier equal to 0. So how much this will be?
0.
0.
Okay.
Yes,
So
sir.
the software will consider self-weight only in one case, right?
Yes, sir.
So that's why that multiplier is except dead load everywhere multiplier will be 0, right?
Yes, sir.
Now there is no confusion because I have seen lot of people are having a confusion why the self-weight multiplier is 1 in one case and 0 in all other case. Because this software, the inbuilt process is that whenever you will create any primary load case, he will apply or he will add self weight into it. So no problem, let him add the self weight into it. But what we will say that, okay, whatever self weight you are calculating, multiply it by 0, and whatever is the value, add it into whatever I have given as a live load or SDL. Clear? Is this is this thing clear?
Yes, sir.
Okay. Now I want, see, on only the two load cases are by default, they are there. You can delete it and you can create again, but that is not required because again you are doing the same thing. So that's why we'll keep dead load and live load as it is. The only thing is that multiplier in one case, in dead load case is 1, and in live load case is 0. Now I want to add new load. So how I can add it? So here I will type the name of the load. Let us say I am typing name of the load as SDL. So superimpose dead load. You may say floor finish, you may say waterproofing, you may say wall. The name is your choice. Okay. Then what is the type of this load? This is a dead load. But is it a self weight? No. It is a additional dead load. That's why I will call it as super dead. Clear?
Yes, sir.
Hello. Okay. Then I will say multiplier will be 0. Once this is clear, I will add new load. Now the load is added. Okay. Right now we are going with only the 3 loads, and then later on we'll add earthquake in X direction, earthquake in Y direction here also. Okay. But just for the time being, we are dealing with only gravity loads. Okay. So click OK. Now the definition has been completed. Okay.
Okay,
Hello.
sir.
Now you are supposed to apply the load. How you will apply? The first thing is that this is base. So you will go to, okay. The first thing is, let
Excuse me,
me,
sir.
yeah.
Sir, what is the difference between dead load and super dead load?
Uh, Actually, both are dead load. You may apply it. See, my concept is that dead load, I'm considering dead load only for self weight.
Okay.
Okay. And any other dead load which is not integral part of the element, that is, which is not a self weight, I will create it in a different primary load case, and that's why I'm saying SDL,
Okay, sir.
superimpose dead load, right?
Yes, sir. Yes, sir.
So that is the difference. Actually, both are dead loads. Both are dead loads. Both are static loads. For our convenience, we are saying that self weight is different and HDL is different. Okay. So go to view, and in view set display options, and in its display options I will click on this, and I will click on this, so that both the windows will remove that three-dimensional view. Okay, now this is your plinth level.
Yes, sir.
Now let us say that this entire plinth level has a parking. Yes or no? See, this
Yes,
is
sir.
our assumption. You may say that, sir, we want a parking of these two only, or these three only, and we want a residential block over here. So in that case, you will have to create loading on this beam or this beam as a loading of the wall load. Clear?
Yes, sir.
Now, how we will calculate the wall load? It's where, let me show you through the picture. Let's say this is your wall. So this is your wall. Uh, my drawing is not that perfect, but just assume it all the straight lines. Okay. Hello.
Yes, sir.
Now you will see that the walls, below the walls we are having our beam. Okay. So let's say I'm having a beam over here. Okay, so this beam will have the wall, and this will be, if I consider as a 1 meter. So if I am considering it as a 1 meter, okay, then let's say this is my height. This is the height, and this is the depth, width. So, or thickness. Let's say this is the thickness, or you may say anything. So I will call it as thickness. Clear?
Yes, sir.
So I will consider 1 meter length along the beam, and then I will say that, let's say density of this BB masonry is 20 kilonewton, 20 kilonewton per cubic meter. Then I will multiply height. So height I
Into
am
T.
in meters multiplied by
T
T
into 1.
in meters. Okay. So height multiplied by thickness multiplied by density. Finally, I will get something in terms of kilonewton per meter. Yes or no?
Yes, sir.
That's why we say that on the beam we are having UDL, that is a load in kilonewton per meter. And this is the calculation. So, how you will find out this H? See, architect will give you the thickness. Architect will give you that 15 or 150 thick wall, BB masonry. Okay, so the thickness is defined by architect. Then height will be defined from floor to floor height. Okay, so if you are having floor to floor height as 3 meter, and then there will be a beam. So minus depth of the beam. Clear?
Yes, sir.
So if I'm saying that depth of the beam above is 450, and height of the floor to floor height is, let's say, 3050. I'm considering everything in mm. So 30 minus 3050 minus 451 will be
2600.
will be equal to h, and then I will convert it in meters, and that will be the height of the wall. Clear?
Yes, sir.
So the thickness is known. Height is calculated with the help of architectural elevations, and you know this from your IS 456 part 1. So it is something between 18 to 20, or it may be different if you are using different material. Sometimes you may have some sort of concrete stone wall, or there may be lightweight uh, uh, ASE blocks. So all that density is given under that IS 456875. You will find the density. But for normal BB masonry, it is in between 18 to 20. Clear? Yes or no?
Yes, sir.
So based on that, you will find out the UDL that you are going to apply in SDL, superimposed dead load. Okay? Yes or no? Now, wherever you are going to apply that loading on all the beams which are carrying vertical walls. Let's say you are having all beams. Let's say I'm selecting these 4 beams. Then I'm selecting these beams. Then let's say I don't have a loading on these beams. Then I will say there is a beam on this side, and these are the beams that are carrying the loading. Okay, so I have selected all beams on which I want to assign STL. Clear? See, this is one story option. Then you can see the 22 frames are selected, and you have selected all the beams where you are supposed to create or construct UDL, construct BB masonry of 150 thick. Okay, and your calculation says that the total load of the BB masonry is something around 8.5 kilonewton per meter. We'll see in practice when we'll be going in a practical problem how to calculate with based on different scenario. But let's say that is working out to be 8.5. Now it is to be assigned to the beams on which that wall load or wall is going you are going to construct in future, right? So the first thing is that I have to select all the beams which are having 8.5 kilonewton per meter as the loading due to BB masonry, and that I will include in STL. Yes or no? Hello? Am I audible?
Yes, sir.
तो आंसर तो दो, समझा या नहीं समझा? Not understood?
No, sir, understood.
Okay. Now, so I have selected the beams. I have calculated the loading that I'm going to assign in category STL. Now I will go to assign because I have to assign. So I will go to assign. Click on assign and click on frame loads. Why I am going in frame loads? Because I have selected frame elements. So go to frame loads and see whether it is a point load. No, it is not a point load. It is a distributed.
Distributed load.
So click on it, and you can get the frame load assignment distributed dialog box. Under that, first choose your category. What is the category?
STL.
Yeah.
Then you can see here what is the type, whether it is a force or moment.
Force.
Yeah, so the force will be highlighted. Now you can see what are the options. See, in this option, you are having three options. One is add to existing load. The meaning of this is that, let's say previously I have I have assigned a load of 2 kilonewton per meter. Now, if I select this and if I write something 8.5, then 2 plus 8.5 will be the total load. Okay?
Yes, sir.
Yes? Hello?
Yes, sir.
Now, I don't want to add to the existing load.
I replace existing load.
So I will go for replace. Now this will help me that by mistake I have applied some 2 kilonewton previously, but actually I don't want that, but I have done that. So now this will, whatever loading that I am going to apply right now will be will, that will be replaced. The previous load will be replaced by this new load. Clear?
Okay,
And
sir.
then if I choose this delete, then whatever is the load over there will be deleted. So I'm going for this replace existing load. Okay. Now this is, you can see this direction and load application. And if you pull down it, you will see that you can apply load in one direction, load in two direction, load in three direction, global X, global Y, but you don't see global Z because that is gravity. That's why it is called gravity. So we'll click on that. Most of the time, this will be the, by default, it will be gravity. But if you want something else, then you have to click on this down arrow and go for your proper choice. Okay, clear?
Yes, sir. Yes, sir.
Now this, right now we are not going for trapezoidal load. So we'll see that under load, everywhere it is 0. Then you will go to this uniform load, and here you will put the amount or the magnitude that you have calculated. Let's say we have calculated 8.5. So I will write 8.5. Don't place minus because gravity. You have chosen gravity. That means gravity will always act towards center of the earth, that is in the vertical downward Z direction. So no need to apply negative over here. Okay.
सर सुपर डेड लोड, सुपर इम्पोर्ट डेड लोड कुछ ज्यादा नहीं ले रहे हम लोग.
अरे फॉरगेट अबाउट मैग्नीट्यूड. मैं बोल रहा हूँ कि मान लो आपका 5 मीटर का फ्लोर टू फ्लोर हाइट है तो वो कम होगा. समझे ना?
यस सर.
सी, हम अभी कोशिश क्या कर रहे हैं, जो भी क्वांटिटी हमने कैलकुलेट किया है बेस्ड ऑन विड्थ एंड डेप्थ एंड डेंसिटी, वो अप्लाई कैसे करना है, राइट?
यस सर.
So it may be 8.5, it may be 7.2, it may be 6.5, sometimes it may be 2.5. I don't know. That depends on your calculation. But जो भी calculation आपने किया वो apply कैसे करेंगे वो हम सीख रहे हैं अभी.
Okay,
Right?
sir.
Okay. So let's say it is 8.5 and click OK. You can see 8.5.
सर
Yeah.
सर ये जो अपन ने आपने वॉल बनाई थी, ये जो बीबी वॉल, ये भी तो एग्जिस्टिंग रहेगी ना सर अपने स्ट्रक्चर में?
स्ट्रक्चर में है, तुम्हारे मॉडल में है क्या?
मॉडल में तो नहीं है.
तो वो कैसे कैलकुलेट करेगा?
अच्छा,
वो आपको कैलकुलेट करना पड़ेगा.
नहीं मैं ऐसे पूछ रहा था कि जो एसडीएल है,
हाँ,
बीम स्लैब कॉलम के अलावा जो भी चीज होगी वो सब एसडीएल में आएगी.
यस यस.
मैं ऐसे पूछ रहा था सर.
नहीं राइट. और वो सारा डिसीजन आपको लेना है एज अ स्ट्रक्चर इंजीनियर.
अच्छा.
You can apply this in dead load also. Not necessary that you should apply it in SDL. You can, or there are many structure engineers who are not going for SDL. They say that it is a dead load, then why I should apply one more SDL? So I will include it in SDL. Even if floor finish also, they say that if it is dead load, we'll apply it dead in the case of dead load. And that's why I have explained that primary load case, whatever magnitude that you are applying, whether on slab or on beam, this software will add a self weight of that member. समझे ना?
Yes, sir.
अगर अगर यहाँ पे मैंने मान लो डेड लोड में डाल दिया, तो what he will consider, the total load on the beam will be 8.5 plus self weight.
Okay.
And that's why that multiplier in dead load case is 1, and in all other load cases is 0.
Because that जो multiplier है वो self weight multiplier है.
Yeah.
That's why 1 और 1 अपन उसको 1 multiply करेंगे यार किसी के साथ.
But
और
see,
अगर
yeah,
दूसरा डेड लोड के अलावा दूसरा आता तो 0 से हो जाएगा सब.
हाँ, तो वो क्या करेगा, मान लो अभी आपने SDL में 8.5 डाल दिया है.
Yes,
Okay.
sir.
But this software will consider it as a additional load plus self weight.
Plus self weight.
So he will again calculate the self weight, but you are giving multiplier 0. That's why everything multiplied by 0 will come out to be 0. And only 8.5 will be applied.
Okay.
Clear हुआ ना concept?
Yes, sir.
या थोड़ा कंफ्यूजिंग है शुरू में लोगों को, मुझे भी 2-3 दिन लगे यार. मैं बोले ये क्या तकलीफ है यार, एवरी टाइम कैसे कैलकुलेट करेगा. सी, सॉफ्टवेयर कैन नॉट हैव two meaning definitions. In one case you will say that add it, in another case you will say deduct it, in third case you will say multiply it. Human can thought, human has a capacity, or every person is having a capacity to think, but software doesn't have the capacity of thinking is not possible for software. So that's why he will go like what day before yesterday I said. He will say that the moment he will find any old person, he will pick him and he will send him to opposite end of the road. क्योंकि उसके पास थॉट प्रोसेस नहीं है, कॉमन सेंस नहीं है जो हमारे पास है. समझे ना?
Yes, sir.
Yes, sir.
या तो उसका कॉमन सेंस हम काम करेंगे और उसका जो एनालिटिकल पावर है उसका हम फायदा लेंगे. that's why we can control the software. Otherwise देखिए सॉफ्टवेयर तो कैलकुलेशन में बहुत फास्ट है. अगर उसको कॉमन सेंस और एनालिसिस और थिंकिंग भी आ गया ना, तो he will not listen us, he will ride on us. Yes or no?
Yes, sir.
तो अगर आप चाहते हो तो people are working on that artificial intelligence. तो उसमें वो प्रोग्राम ऐसे कर रहे हैं कि he can think. जैसे जैसे वो आगे बढ़ेगा ना, तो बाद में हो सकता है कि सॉफ्टवेयर हमारी बात विल नॉट बी इन आवर कंट्रोल, वी विल बी इन सॉफ्टवेयर कंट्रोल. तो वो हमें डिक्टेट करेगा, ये करो वो करो, और हमें करना पड़ेगा. तो वो नहीं होगा, क्योंकि whatever may be the thing is that you cannot create a software who will think on its own. He cannot create the ideas. He will follow your program, but he will not create the ideas. We as a human, we can create the ideas. हर एक को अलग अलग आइडिया आती है ना. Yes?
Yes, sir.
हाँ, तो that's why we are in control. Okay, so वो थोड़ा अलग part हुआ. So this is how you can apply. Now let's say that on these beams, the loading that you have calculated is something around 3.25. So I have selected them. And again, I'm going to assign frame loads distributed, and in distributed, again, I will see that SDL is active, then force is active, gravity is active, replace existing is active, and in this, there is no trapezoidal loads. And here, instead of that 8.5, now I will say that 3.25. That is how I have calculated. Okay. So you can see the load is applied. दिख रहा है आपको?
Yes, sir.
Sir.
Now, if you want to recheck it, right click on any beam and go to loads, and you will see that under load pattern, HDL uniform force 8.5. Clear? Right click on the
Sir.
beam, go to loads, under load pattern, HDL uniform force 3.25. So this way also you can check your model whether you have done it correctly, because many times ऐसा होता है ना, by mistake हम लोग ज्यादा, अब मान लो now let's say that I want to change it. Let's say I want to change this. Okay, so I'm selecting this beam. Okay, I want to change this also, and instead of 3.5, let's say that I want to apply, so the 3.25 is not the load. I have done a wrong calculation. Now I am correcting it, and I find that instead of 3.25, it is 1.5. Okay, so I want to change it. So again, the same process. I have selected the members, and I will go to assign, and I will go to frame loads, distributed, under distributed, replace existing. So 3.25 will be replaced by 1.5. You can see. And now if I right click on it, you can see 1.5. Clear?
Yes, sir.
Now let's say that this load 8.5, I want some additional load of 1.5 on this member, or maybe on this member and on this member. For some XYZ reason, I want that it should be added by say 1.5 or let's say 2.5. Okay, so I have selected the beams, and I will go to assign, and in assign I will go to frame load, distributed, under distributed, instead of replace I will go add to existing load, and there I will write that quantity, let's say 2.5. So the magnitude. Now you can see, now if I right click on it, now you can see 8.5 and 2.5. Clear?
Yes, sir.
So this is how you can use all options for adding load on the elements. So here we are applying UDL on elements. Let's say this load, let's say you want to apply, instead of this UDL, you want to apply trapezoidal load. Okay. Yes or no? See, this is my beam. Let's say this is my beam. This is my support of this beam. This is the support of this beam, and this is my total length. So this is my total length, and I am having UDL not entirely on the entire beam, but it is having something upon, say, let's say this is L equal to say 2.5, just say, and this is 1 meter, right? And the magnitude of this load is say 7.20 kilonewton per meter. So this is the loading that you have to apply. Okay. Hello.
Yes, sir.
Now how this can be applied? See, this calculation is your part, because this will differ from every project. So all I'm trying to concentrate on that thing. 1 minute. So let's say if I want to apply this, how I can apply? Okay. So let us consider this 7.2 and this 1 and 2.5 will measure it over here. Okay. So I will remove this and I will check that. So if I want to check, let's say you can check it over here as it is something around 6 meter. But if you want to double check, you can go to that. You can go to geometry and you can see this. It is 8 things. Okay. Or you can go to draw, and in draw you can go to draw dimension line. So draw dimension line and pick point from this point to this point. So you can see 8 meter. So the total length of the member is 8 meter. And let's see, on 8 meter member, you want to apply a loading of say 7.2 up to 3.5. Okay, so the total length of the member is 8 meter, and you want to apply a loading up to 3.5 from left end. Yes. Hello.
Yes, sir.
So this is the topic. Let's say this is up to, say this is up to 3.5. And you want to apply that, and you want to remove this 11. Okay, you don't want that 11, or you may say that okay, so we'll remove that. Okay, so let's see how we can do it. So the first thing is that select the beam. So I'm selecting this beam. Let me go to select. So I'm selecting this beam. So the selection has been completed. One frame is selected, and I will go to assign, and in assign I will go to frame loads, and in frame loads I will go to distributed, and under distributed you will see that the first thing is that I will replace it. So here I will put UDL, I will put as 0. Okay. So never ever to go and produce 0 over here. And now here you can see a relative distance from end I, and this is absolute distance from end I. Okay.
Yes, sir.
Now end I means start point, and end J means end point. Okay. So end I, what is the relative distance? 0. And what is the load value? How much we said? 7.2. So I will say 7.2. Okay. At a relative distance equal to 3.5. No, absolute distance 3.5. What is the value? 7.2. Okay.
Okay,
Then
sir.
now here I will say again relative distance equal to 3.5. The value is 0.
9.20.
And relative distance equal to 8. The value is 0. Clear?
Yes, sir.
And then click OK, and you can see, if now you can see this loads. So here you will see that 7.2 kilonewton is 0, then 7.2 kilonewton up to 3.5, it is 7.2, and remaining will be 0. Clear?
Yes, sir.
Now one more thing. Now this is not on your grid line, so you cannot get the elevation. How you will get the elevation? let's say we'll go in the elevation so that it will be more clear to you. See, if I go to elevation number 4, I will see 8.5, 8.5 and 3.2, 25. Let's see, elevation number 4. So if I go to elevation, and if I go to elevation number 4, you
Okay.
will see, you will see here 8.5, 8.5 and 3.25. Only at plinth level, because above floors you have not added any loading. Clear?
Yes, sir.
So this is also a way that you can check your model whether it is correct or not, or some if you have if you are checking someone else's model, then you can see whether he has done it rightly or not. Clear? So let us again go back to plinth level. So how I can find out this in elevation? Because there is no grid line. And you know that elevation is available only on the grid lines, whether it is A, B, C, D or 1, 2, 3, 4, whatever grid lines you have created, the elevation is available only on those grid lines. But this is your, you have created this beam with the help of offset or any other different method that you have learned. Somehow you have created, but there is no grid line. So, and I want to see that elevation also. Then very simple, you have to go to draw, and you can see draw develop elevation definition. Okay. So click on this. You can see elevation 1. You can write the name anything. You can say anything, but let us keep the elevation like that. And say okay, and from this point to this point, and clear, and then you can see the elevation is here. Hello, are you getting it?
No, sir.
नहीं हुआ. Okay. Okay, the load is applied. See how I can create elevation from this point to this point. So I know that there is a joint. There is a joint. So I can create the elevation using draw developed elevation option. Is this much clear?
Yes, sir. Yes, sir.
Okay. And see, any elevation that is not falling on grid line, you have to develop it. That's why we are saying that developed elevation. It is not a elevation by default, because by default you are getting elevation lines only on the grid line. But you want other elevation, and in that case you will say that you want to develop the elevation, and that's why we are going in draw option, and the draw we are going draw developed elevation. You can see draw develop elevation definition. Click on it, then you can name the elevation. So here you will say that say x1 x1. So I will say x1 dash x1. Any name as per your choice. Click on that, and then click on the joint, and then click on another joint, and press enter.
Okay, sir. Understood.
Clear? थोड़ा
Yes,
थोड़ा
sir.
थोड़ा difficult है, a little bit. So, and now you can go to display, and under display you can go to load assign frame, and in frame I will go to STL and click OK. You can see the here.
Yes, sir.
Got it?
Yes, sir.
So this is the part UDL. So you can create a part UDL, you can create n number of elevations, whether they are on grid line or not. You can, but in that case, you have to go for some certain uh, drawing. Let's say you want elevation on this line. You want elevation on this line, and okay, we'll go for this line. Okay, so what I am doing, I am going to draw. Then I am going to draw develop elevation,
elevation day.
and here I will write the name of the elevation as y1 y1, whatever, that is your choice. नाम आप कुछ भी दे सकते हो. नाम में क्या रखा है? y1 y1, and I will click OK, and then I will click on one point, and then I will click on another point, and then I will enter. And so this is my develop elevation y1 y1, and I will go to display, and
Load
go to load assign.
frame.
Under frame, I will go to STL and click
Yeah.
OK. You can see. Clear?
Yes, sir.
sir.
मजा आ रहा है कि नहीं आ रहा है?
आ रहा सर.
यस सर.
यस सर, मजा आ रहा है.
थोड़ा थोड़ा मैं बेसिक जा रहा हूं, क्योंकि ये इतना बेसिक आपको कोई बताएगा नहीं. ये इतना मुझे भी पता है. अब मान लो, if you go to elevation, you will see all develop elevations are appearing here. तो इनिशियली उसने आपको क्या क्या दिया था? ABCD 1 2 3 4. आप बोले नहीं, उतना से तो मेरा काम नहीं बनता है, तो मैंने आपको elevation 1 भी दिया, x11. Actually this is the elevation, and x11 is same, so we'll delete that elevation 1. So you can delete elevation. Yes, now you can see x1 x1, y1 y1. So you can say x2 x2, y2 y2, n number of elevation you can create, and so that it the entire model will be under your control. कॉन्फिडेंटली आप बोल सकते हैं कि नहीं, ये इसमें ये गलत है, देखो यहाँ पे है, राइट. Then let's go to assign, clear display of assign. Then I will go to plan. So in plan, I will go over here, and you can see now this is about drawing UDL or anything. Let us say that I want to apply a trapezoidal load. So this is my one beam. And I'm having a loading something like this. And let's say total length is anything 8 meter. So the magnitude over here, so you can say it is again say 10 kilonewton. Any magnitude you can go for 10 kilonewton per meter. Now this distance is something around say 2 meter. Then this distance is something around 3 meters. So what will be this distance? 8 minus 3 minus 2. So it will be 3. Yes? Hello?
Yes sir.
Sir.
So if we are interested in creating a UDL of this kind, many times it may you may have that type of UDL. Normally in residential slab, this type of UDL is not appearing. But let us say that in complicated structure, you might get such type of loading. How you will create this loading on any beam of this? So we'll select that. So let us see if I see this. So this beam is again, if I go to geometry, this beam is again 8 meter. Okay, so this 8 is perfectly suitable to this. So I will select this beam, right? And then I will go to assign, and in assign, I will go to frame loads, and in frame loads, I will go to distributed, and under distributed, I will see that this is 0. So let me remove that. Okay, so STL, now you can see at 0, we are having a loading intensity as 0. At a distance of 2 meter, we are having loading intensity as 10. Okay, at a distance of 2 plus 3, that is 5 meter, we are having intensity as 10. And then at a distance equal to 8 meter, that is from I end. So 8 meter, you are having intensity as 0. Okay, just go ahead. So whatever loading that you have created over here previously under STL category will be replaced by this load. Okay, so click on that. Now you can see you are having the loading, but you cannot see in elevation. So you will have to select the elevation. So what I am going to do again, go to draw developed elevation. Then I will write the name as Y2Y2. Let's say Y2 dash Y2. Okay. And then I will click OK. And then I will click on this point and in this point and enter. So the elevation is Y2 is appearing before you, and then you will go and see display. And where is that? The display load assign frame under STL category. You can see. बराबर है?
Yes, sir.
अब मजा आएगा. So just go ahead with this practice. Okay.
Yes, sir.
तो आप क्या करो, फॉरगेट अबाउट दैट क्वांटिटी. आप कुछ भी लोड लगा दो, कुछ भी लेंथ ले लो, कुछ भी लोड लगा लो. एक बार प्राइमरी लोड दैट पार्ट यूडीएल दे दो, एक बार फुल यूडीएल दे दो, फिर उसको रिमूव करो, फिर उसको ट्रापेजॉइडल दे दो, फिर उसको ट्रायंगुलर दे दो. एवरीथिंग इज पॉसिबल. आपको थोड़ा प्रैक्टिस करना पड़ेगा, राइट?
Yes, sir.
तो आई थिंक इट इज बेटर टू स्टॉप ओवर हियर, क्योंकि बहुत सारे कमांड्स मैंने बताए हैं. नेक्स्ट डे आफ्टर टुमारो I will go ahead and I will see how the slab load is applied. Right?
Okay.
Any doubt? Please go ahead. And some of you who were asking me some queries, for all those who don't have any query, they may quit, because now I'm not going for any additional session. But all those who are having some queries and they want it to be clear from me will carry out the session for maybe 10-15 minutes as per their queries. Yes, अविनाश कुमार,
Yes, sir.
कुछ कहना चाहते हो?
नहीं सर.
नहीं. ओके.
सर एक्चुअली टाइम का इशू था, वो कभी 7 बजे कभी 7:30 में थोड़ा इशू हो रहा था, तो एक टाइम फिक्स हो जाता ज्यादा बेटर था.
नहीं नहीं नहीं, अभी हमेशा 7:30 के लिए किया है मैंने.
ओके सर.
अभी ऐसा कभी नहीं होगा कि 7 बजे शुरू होगा. अगर मेरे पास कनेक्टिविटी सही है, क्योंकि नाउ दिस इज अ रेनी सीजन, and in rainy season many times you see that even if you are having Wi-Fi or whatever, if the weather is cloudy, then you don't get the signals. Only then will have to shift. Otherwise 7:30 will be our standard time. I hope everybody is okay with that time.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. Otherwise, I can go with 7 also. I don't mind. But some of you are working in any office, and they are not able to reach to their home at before 7. That's why we have made it 7:30. Otherwise, for LBA, 7 is the standard time. But only for your batch, we are making it 7:30.
Okay, sir.
Okay. Yes, हेमा केदारी जी बोलिए. काही अडचण आहे का?
sir.
आहे.
No, sir.
ओके ओके. थोड़ा थोड़ा बीच में मुझे मराठी बोलना अच्छा लगता है. आप लोगों को भी मराठी सुनना अच्छा लगेगा, भले समझे नहीं समझे. यस.
सर
ओके. अरे
सर एक
अक्कल
डाऊट था.
या.
एक डाऊट होता सर, ते मी काय केलं, फ्लोर्स वगैरे सगळे ऍड केले. त्याच्यात कॉलम्स पण ऍड केले आणि बीम्स पण ऍड केले आणि स्लॅब पण ऍड केला होता. आणि त्यानंतर मी त्याची जी फ्लोर हाईट आहे ती मी चेंज केली.
ओके.
तर ते जी कॉलमची हाईट आहे ती चेंज नाही आली, म्हणजे ती तेवढीच राहिली. तर ते ऑटोमॅटिक चेंज होत नाही का तसं?
व्हायला पाहिजे ना. See, if you are going to this, let's see that. We'll go to plinth, and I will assign clear display of assign, so everything is gone. And let's see. Right now, if I go to this edit and edit model, edit story and grid system, and if I go to this, right now you can see everywhere you are having 333. Let's say if this is something 5, and this is something, say, 4.5, and let's say this is 9. Okay, so I have changed it. Clear? So I am saying okay to this, then I am saying okay to this. And if I go now, if I go in the elevation, I should get that different height. So if I go, let's say I'm going in elevation number 3. So if I go to elevation 3, you can see it is changed.
Yes, sir.
Yes. So shayad something you have not done it like this. So go to edit, go to edit stories, and here go to modify show story data, and into this you can change height
Sure.
over here.
Yes, sir.
ऐसे ही किया था ना?
यस सर, ऐसे ही किया था.
So
लेकिन
then what was the problem? दोबारा करके देखना, शायद
yes sir,
you
फिर से करके देखते हैं सर.
you might have done something wrong that you do not remember, but do it again like this and see whether you are getting the effect or not. It has to be.
Yes sir.
It has to be.
सर मैंने वो ये किया था, उसको मास्टर स्टोरी किया था फर्स्ट फ्लोर को और सेकंड फ्लोर को, और वो अल्टरनेट मैंने यहाँ पे अप्लाई किया था. तो शायद उसके
नहीं
वजह से
उसका
नहीं हुआ
कुछ
होगा
नहीं,
शायद,
उसका कुछ नहीं.
क्योंकि यहाँ पे जो ऑप्शन है 1 स्टोरी, वहां पर मैंने सिमिलर स्टोरी किया था और उसके बाद डिस्टेंस चेंज किया, तो इसलिए नहीं हुआ होगा शायद.
नहीं नो, वो सिमिलर स्टोरी ऑप्शन निकाल दो पहले, क्योंकि सिमिलर स्टोरी में क्या होता है, see the height of the column is at least either it will be this or it will be this. ऐसा नहीं होगा ना कि कॉलम हाइट, सिमिलर स्टोरी में कॉलम हाइट अलग है.
Yes,
ऐसा
sir.
नहीं होगा.
इसलिए हुआ होगा.
Yeah. So that's why that might have, yeah, you are getting correct right now. So make all story in master story, say everybody to know, and similar also you can say none, and then you can change it.
Okay sir.
Okay. Yes, any other query? Quickly.
No, sir.
Yes, Shahaji Patil, काहीतरी विचारायचंय. Yes, Chaji, want to ask me anything? No. Yeah, Hema Kedari wants to ask me something. Hello.
I think Hema is not present.
Yeah, she is also not, but here the striking. Yes, Abhishek want to ask me something. Yes.
यस सर. सर मैं पूछा उस दिन आपने रेस्टोरेंट्स का बताया था, वो समझ नहीं आया था सर मेरे को.
क्या?
रेस्टोरेंट्स था ना सर वो एक.
Restraint.
हाँ सर, हाँ सर.
Okay, let us go to that. See, this is my 3D view. Okay, so this is X, this is Y, and this is Z. अब ध्यान से देखना. Okay.
Yes sir.
Hello. So
Yes, sir.
I'm having a point over here. So this is my point. Okay. It may have some label 1, 2, 3, 4, X, Y, Z, anything. Now, if this point, I want it free to move in Y direction. It is free to move in X direction, and it is free to move in Z direction, as well as it is free to rotate about X axis, about Y axis, about Z axis. So that is called a free joint. Okay. So it is free. So if some force is applied in this direction, it might move along the y-axis. If some force is applied in z direction, it might move in z-axis. And if some force is applied in z direction, it might move in the z direction. Yes, so that is a degree of freedom. So you are free to move in x, y, and z direction. Clear?
Yes sir.
Now, let us consider again another situation. So I will do it. So again, this is my x, this is my z. This is y. This is x, and this is z. Let us say here I am having a roller support. And in this direction also, I am having that support. So the roller support is applied. So it can move in x direction. It can move in y direction. But can it move in z direction? No. The roller is not able to move perpendicular to its plane of support. So a direction is restricted. So this is a roller support. Okay. So
सर,
here,
इसके 2 रिएक्शन निकलेंगे ना सर?
yeah.
इसके 2 रिएक्शन निकलेंगे ना सर?
नहीं, रिएक्शन एक ही निकलेगा, क्योंकि इन बोथ द एक्स एंड वाई डायरेक्शन इट इज फ्री टू मूव.
Okay.
See, whenever something is free, there will be no reaction, right?
Yes sir.
मान लो कि आप अपने पिताजी को बोल रहे हो कि पिताजी मुझे दिल्ली जाना है. पिताजी ने आपको बोला अच्छा जा सकते हो. Then there will be no reaction. Reaction will be only when आपके पिताजी ने बोला नहीं, you cannot go to Delhi, you have to sit in home and you have to study. Then you will, why sir, why I cannot go? So that is the reaction.
Yes sir.
So the reaction will come in picture only when you are restrained to, or you are not allowed what you want to do. Okay.
Yes sir.
Now this roller is not allowing to move in Z direction. So the reaction will come only in Z direction. The roller is not restraining to move in Y direction, not restraining to move in X direction. So the reaction will be only in Z axis. So I can say RZ, or in our term, you will say that UZ. Okay, UZ. Clear?
Yes, sir.
Now, now let's say you are having again same thing. X, Y, and Z. Now here you are providing now hinge. Hinge will not allow you to move in Y direction, will not allow you to move in X direction, will not allow you to move in Z direction. So there will be reaction in all three lines, but hinge cannot resist the rotation. So you can have a rotation like this, you can have a rotation like this, or you can have a rotation like this. So there will be no. So if I say this is theta y, it is allowed. If I say this is theta x, it is allowed. And if I say this as theta z, so no moment, only reaction in X direction, reaction in X direction, reaction in Y direction, as well as reaction in Z direction. So the three reaction will come in case of hinge. And if it is fixed, that means it will not allow you to move in any direction, as well as it will not allow you to rotate about any direction.
Yes, sir.
Clear?
Yes, sir.
Now we'll go and see that picture. Let us go back at the plan, and we'll go at base. Let us say I'm selecting one joint and I'm going to assign, and under joint I'm going to restraint. And now here you can see, if I click on this, you can see that you are free to move in X, Y, and Z. You are free to rotate about X, Y, and Z. So nothing is restrained. So there will be no reaction. Right?
Yes, sir.
Now, if I see roller, you will see that only the reaction in Z direction is coming in picture, because you're not allowed to move in Z direction. You can move in X direction, you can move in Y direction, you can rotate about all axes. And that's why you are only restrained in Z direction, and there will be reaction in the Z direction. Whether positive, negative, that is the what type of forces are coming. But there will be a reaction in Z direction. Right?
Yes,
if I click on hinge, you will see that hinge will not allow you to move in X, Y, and Z, but it does not
rotation is allowed.
rotate. It allows rotation about X, Y, and Z. So there is no reaction in terms of MZ, MX, MY. And if I click on fix, you can see everything is restrained.
Yes, sir.
जब भी आपको कोई चीज समझ में नहीं आती है ना, तो कॉमन सेंस का यूटिलाइजेशन करके उसको इमेजिन करने की कोशिश करो। यार क्यों ऐसा होता है, मुझे गुस्सा क्यों आता है? क्योंकि सामने वाला आपको कुछ कहता है, अगर वो कुछ नहीं कहेगा तो कुछ नहीं होगा। So it depends.
Yes, sir.
So action and reaction are always equal and opposite. Clear?
Yes, sir.
Actually it's a law of nature, but पता नहीं न्यूटन को उसके लिए बहुत सारे प्राइज मिले। और वो तो लॉ है, बराबर ना? अगर मैं आप लोगों से प्यार से बात करूंगा तो आप लोग मुझसे प्यार से बात करोगे। लॉ है।
यस सर।
अगर मैं आप लोगों को गालियां दे दूं तो आप लोग मुझे 10 गालियां देंगे और बोलेंगे कि आपके पास है क्या, हमारे पास उससे ज्यादा है, बिकॉज दैट इज अ लॉ।
यस सर।
So try to think, because I always say that civil engineering is a common sense. Civil engineering is just following laws of nature. तो हमेशा नेचर में क्या हो सकता है वो ढूंढो, आपको पता चलेगा। यू कैन स्टार्ट इमेजिनिंग द थिंग्स।
यस सर, जो ये रोलर सपोर्ट वगैरह है सर, ये तो मतलब कि सिर्फ स्टील स्ट्रक्चर में होता होगा ना सर ये?
सभी स्ट्रक्चर में होता है, ऐसा किसने बताया कि स्टील में ही होता है?
नहीं सर, ऐसा कोई एग्जांपल मतलब हो तो रोलर में।
नहीं नहीं, यू कैन सी। आपने ब्रिजेस देखे?
यस सर।
यस सर, ब्रिज।
ब्रिजेस के वो गर्डर्स देख लो, गर्डर के बीच बिलो वहां पे वो कंक्रीट के रोलर है, जिसकी वजह से मोशन ट्रांसफर होता है कॉलम पर। किसी भी फ्लाईओवर पे जा दो, जाके वो जो गर्डर कॉलम पर सपोर्ट हो रहा है ना, वो देख लो।
यस सर, याद आ गया, याद आ गया सर, देखा है वो तो मैंने।
भैया वापस नेचर में जाके देखना है और कुछ नहीं।
यस सर। यस सर, नहीं कभी सर बिल्डिंग में नहीं देखा मतलब।
अगर किसी ने बिल्डिंग वैसे डिफाइन की तो हो जाएगा।
यस सर।
सी
थैंक यू सर।
कंक्रीट, नहीं मैं आपको बता दूं, ओके कोई बात नहीं। सी इन कंक्रीट, आई एम नॉट टॉकिंग अबाउट रोलर, but let us say you are having something like this. So this is your member, and if the reinforcement that you are showing is something like this. आपको नहीं लगता ये हिंज हो गया?
यस सर।
तो ये सारी चीजें हैं, थोड़ा थोड़ा ट्राई टू फाइंड आउट मोर डिटेल्स। और उसके लिए आपको मैं कहूँगा गूगल गूगल बहुत बढ़िया है आजकल। कि गूगल पे जाओ और बोलो शो मी द डिटेलिंग फॉर हिंज इन कॉन्क्रीट स्ट्रक्चर्स, शायद आपको ये ऐसी कुछ चीजें बता देगा। गूगल पे सर्च करो यार, सब कुछ मिलता है।
यस सर।
पैसा छोड़ के सब मिलता है। यस, एनी अदर क्वेरी?
नो सर.
ओके, अकोलकर चाललंय ना बरं?
हो सर.
काही हरकत नाही. ओके ओके. यस, एनीबडी? प्रीतम, प्रियदर्शनी और मंसूर जहान, यू आर नॉट आस्किंग मी एनी? या मसूर जहान. Yes, hello. Am I audible?
Yes, sir. I will just practice and come back, sir, if I have any query.
Yeah, but try to create so many queries so that that will help you. And I am the only person. मुझे आप जितने queries हैं, उतना अच्छा लगता है. Forget about what you are asking. क्योंकि जो नहीं समझता वही लोग पूछेंगे ना. So don't hesitate asking me any query. That will help you. That will help others also.
Yes, sir.
Okay? Yeah. I think today's queries are over, I think. So we'll conclude today's session. Yes? Can I
Yes, sir.
conclude?
Yes, sir.
Okay. Thank you.
Good night.
Good night. Good night.
जे आहे ते